Hi, everybody. It's Dr. Schulman, and we're going to do 6G, the last part of the first part of geometry, which is knowing strategies for composing, decomposing, and manipulating figures. There's going to be a lot of isometry in here, which we've seen, and a bunch of other pieces. I just finished making your quiz. This first quiz, there's going to be 3 quizzes for geometry before the test. This one's going to be the longest one because it had 8 sections, so I also made it worth the most points. There's some multiple choice, there's some fill in. I try to vary it as much as I could and hit as many of the topics as I could. So this one's gonna be a little tough, but as long as you do your delta, you should be fine. So I'm gonna share my screen. We're gonna jump into it. And this is 6G, the last part of geometry. Who's excited? So I'm here, which is this last one, which is E, F, and G. This one's going to be kind of long. Strategies for composing, which is put together, decomposing, ripping apart, and manipulating figures. So there's a lot here. There's going to be a lot here, but guess what? We can figure it out together. So I'm in my delta 6G, and there's a lot of them. So let's just have at it. I've given you a tons of extra informations and lessons, but I think it's time we just kind of have at these for this one. So we're gonna start right from the skills, translations, beautiful. So this is a translation, which is a slide. So we're just sliding it. It's isometric, which means it's going to be the same size and shape. So if I translate it, one to the left, 1 unit to the left. So this is what it could actually look like in notation form. If this is point A of -5, -1, we want to do a translation of 1 to the left, that's -1, and 1 down, so -1. This is your X, that's your Y. So your A prime, your new unit, is going to be 1 to the left, which is -6, and 1 down, which will be -2. And that is your first one. We're sliding this point 1 to the left and 1 down. That's -6, -2. Ta-da! Beautiful, beautiful. All right, let's keep going. All right, so here we're going to do a translation. Map figure F onto G. So this is the pre-image, and that's the image. Okay, so we're going how many? We're going 1, 2, 3. I believe it's 4 to the right. We're going 4 units to the right, and we're gonna go. You can use any point you want, but we're starting at 9, we're ending at 4. So 1, 2, sorry, 1, 2, 1, 2, 3, 4, 5. I believe it's 5. 5 down. We're going down 5. So I believe this is this one. The translation is going to be +4, -5. That's it in notations. Let's see if it matches. We did it. Isn't that cool? All right, let's do another one. All right, so now we're going to translate one on a graph. I know it's not on the coordinate plane, but we'll get there. So plot the points of the figure. So we're going, this translated is 6 to the left. So it's going to be -6 and -4. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1. Oh, we can just count 1, 2 from here, right? Because we already have the points. 1, 2, 3, up 1. 1, 2, 3, up 1. Cool. And now we have to go down, which is 1. We can just count from here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then we're over 1, 2, 3, 4. 1, 2, 3, 4. Perfect. Sorry, one of these is off. This should be down 1, 2, 3, 4, 5, 6, 7, and then over 2. This should be over 1, 2, and then this should be over 1, 2, 3, 4. 1, 2, 3, 4. It's got to look like the same size and shape. Otherwise, you made a mistake, you know? You can do it point by point, but I just thought it'd be faster to count. Ta-da! Beautiful. All right, now we get to reflect. So remember, reflection is going to look like this. It's reflection over the line y equals 3. So that's this line. How do we know that's the line? The only thing we know about this line is that y equals 3. X could be whatever it wants. You can do 0, 1, 2. So at the point 0, 3, 1, 3, and 2, 3. There's your line. And then all we have to do is count. We're 2 down, so 2 down. From this point, we're 1, 2, 3, 4, and then over 1. So 1, 2, 3, 4, and over 1. Here we go in 1, 2, 3, 4, 1, 2, 3, 4. And from here, we're going up 1 over 1. So up 1 over 1. There it is. Beautiful. Oh, okay. Oh, yeah, because I didn't flip it. I just counted, but the other one should be 1 extra. So I had 1 point wrong. That's okay. Let's do another one. So here's the point -1. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. You can write the point and then just change the value. So this is up 1 over 1, down 1 over 1. From here, we're going to go back 1, 2, 3, 1 over. 1, 2, 3, 1 over. Okay, here we're going 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It should be along with this one. Yay, we did it. Should look like the exact same shape, just flipped over. There's the reflection. All right. So here's a graphically one. So we have the point U. We'll actually do this one algebraically. So U is the point 5, 3. We're going to reflect it over the y-axis. So there's rules for all of them if you want to know. You can count to the y and count over. Basically, we're going to keep our y, but our x is going to change. So u prime, when we reflect over the y-axis, there's the notation. U prime is going to be -5, 3. The rule for this one is just x, and then we just make it a, sorry, it's -xy to flip over the y-axis. So -5, 3. There's u prime. U is 5, 3. U prime is -5, 3. And there's geometry. What does this say? The x-coordinate changes sign. Now I wrote that too. Ah, isn't that fun? There it is. All right, let's keep going. Some more reflection. So now I have the point 6, -4 is reflected over the x-axis. So if it's over the x-axis now, the y is going to change, the x is going to stay the same. So the y is going to change, the x is going to stay the same. So that's just got to be opposite, right? So it's 6, 4. Oh, but it flips twice. Is over the x-axis, we did it. Then it's reflected over the y-axis. Oh, so it's back where it started. We reflected over the x, then over the y. We're back where we started. What? Oh, yeah. Well, I had the first one right, but then the other one has to change. So they're both, it's going to be a flip and then flip again. All right, let's do it again. Really good problem. So 1, -6 is reflected over the x-axis. So x-axis means that the x is going to flipping over the x-axis. So we can actually draw this. 1, 1, 2, 3, 4, 5, 6. So here's our point P. P prime is reflected over the x-axis. So here it becomes, here's P prime, which is -1, -6. Oh, sorry. It's at x-axis, which is here. So this is going to be 1, +6. P prime is 1, +6. And then it's reflected over the y, so it's going to be a negative 1, 6. That's p double prime. Notice that it changes every time. If you want to do this in it's composition, so this would be written in notation. This is always first. This is always second. So this would be reflection over the x-axis, reflection over the y-axis. So that's how it'd be written out if it was just in notation form with the little circle in the middle, which stands for composition of functions. So we know the answer for p double prime is negative 1, 6. One of the really common problems that they always give, ours looks the same, beautiful, is that if we reflect something over two parallel lines, so if I reflect it over one parallel line, it's backwards, but if I reflect it again, so reflecting over two parallel lines is the same thing as a translation. It's a really common question you'll see. All right, now we get to spin. Let's spin. All right, so rotating it 180 degrees. So rotating at 90 is going to put it here. 180 is going to put it here. We know it's in this box. It's down here. All right. But it's counterclockwise. So here, which is still the same. So follow the guided instructions below. Draw a circle at the center of the rotation. Okay. All right, so I have to touch one of the vertices. There we go. So there's that. Your line must go through, click and drag and draw a line through the yellow center to the vertex. Okay. Now sorry. Now draw a line. Now draw a line through the yellow center that is perpendicular. Okay, so this is a line perpendicular, has to be this way. There's a perpendicular line, makes 90-degree angles. The slope of the first line is -3, and the slope you draw is 1. Oh, so it's not perfect. We're going, look, we rise up 1, 2, 3, we run over 4. So now we have to go up 4 and run over 1, 2, 3. There it is. Now we get to rotate this 180 degrees. I know. So this is 90, and that's 180. What a good problem. Oh, now I get all the points so I can see it. Animate the rotation again. Boom. So -6, 3 became 6, -3. Notice that it's just a change in the terms. You'll see the pattern. The point -5, 2 becomes 5, -2. This point is -1, 3, and it becomes 1, -3. So we just change both signs to go 180. Both signs change. This is 4, -3. That's the roll. And this is 4, -6. 4, -6. Yeah, perfect. Let's do this one more time. That was really well done. Nice. All right. All right. Why is it only 180? Can we do a one that's not 180? Yeah, let's do a 90 because it's going to be a different rule. So draw a circle so that one of the vertices touch it. Cool. There we go. Now we have to draw a line. I gotta hit one of these things. There we go. That's what I have. Oh, I have to put the dot there. Your line must go to the center and also the vertex. That's what I have. All right, I'll do a different one. Want to be all weird about it. Oh, it's because I'm not on the center. Mine must go to the center and also the vertex on the dot. That's what I'm doing. All right, well, let's do one last one. Can I restart this thing? Your line must go through the center of the circle and also the vertex on the dotted circle. Oh, it's got to go through this specific one. Otherwise, we can't spin it. Okay, okay, I see what I have to do. So from this dot to that dot. Nice. And this slope is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So it's 7, 3. So this means it's got to go -7/3. -7/3. Nice. Now let's rotate it 90 degrees. They want it clockwise, so it's -90. That's what this one is. This is the rotation from the origin -90 because we're going clockwise. So like the clock, let's go 90. Boom. So here we go. Okay, so the first one was 1, 1. Now it's 1, -1. So I'm pretty sure this first one stays the same for all of them, and the second one changes to -5, -1. Well, let's try it then. This point was 5, 1, and now it's -5, 1, -5. Oh, because it switches to. So it switches and changes. So there's little rules for all of them, for all of the rotation rules. Let's find a good image. Here we go. So 90, well, this is ours. Ours is basically 270. So I might as well put them in here for you. So rotation around the origin 90 degrees, x, y becomes -yx, rotation of 180, x, y, you just change the signs, -x, -y, rotation of 270. These are all counterclockwise the way it should be. It's going to be y -x. And then 360, it stays the same. It comes right back where it started. XY goes to XY. Cool. This is really pretty. I like this. All right, so if we're going 270, which is the same thing as -90, which is what we have, the y goes in the front, and then we flip the x. So the y goes in the front, we flip the x. I just don't want to look at the graph anymore. The y goes to the front, we flip the x. The y goes to the front, we flip the x. Cool. Cool. And these are your rules. All right. So which transformation goes from A to B? This is a reflection over the x-axis. Nice. It's easy when it's just done for you and you just have to look at it. All right, so let's do one. To go from here to here, this is a rotation of 90 degrees. Oh, wait, we're going from B to C? C is the result of B. Okay, so this is, we're going 270 or 90 degrees clockwise, which we never do. Nice. So practice with them. You'll see them. Oh, here's a discovery one. All right, press try to test the transformation. It is I believe it's got to be to go from there to there. I think it's just a reflection over the y equals x line. Or we can, rotation followed. If we rotated 180 degrees counterclockwise, followed by a reflection over, I don't know. I believe, okay, so this is just reflected over this line, y equals x. That's what it is. But we have to do it twice. So I believe if I reflect it here, and then I got to reflect it twice. So it's a reflection over the y-axis, and then a reflection over the x-axis. Is the same thing as reflecting it over the y equals x line. Let's see if that works. Oh, but I have to choose two different. Hmm. Let's do a rotation and see what happens. All right, so if I go 90 degrees clockwise, I can reflect it over the 90 degrees clockwise will bring it here. Rotation. Okay, and let's try it that way. Nice. Cool. I would have just done one. It was hard for me to do two instead of one. There's probably a ton of ways you can do it. No, well, I guess only two. All right, let's do another one. So how do you go from here? I believe it's a reflection over the x-axis, followed by a reflection over the y-axis. Again, with this two different businesses, so we got to do a rotation of 90 degrees counterclockwise and a reflection over the y. That should work. Yeah, why not? Let's try it. Oh, so we had to do a translation. Yeah, I was wrong. Really cool. All right, let's do one more of these. These are tough. So I believe if I reflect it and then I translate it. So it's a reflection over the y-axis, followed by a translation. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Followed by a translation, 7 down. I think that's what it is. So practice these. These are fun. I had a count, which is okay. Okay, so let's do another one. Now we're doing some congruence. Use the drop down. So we rotate it, we reflect it. A rotation, 90 degrees clockwise, followed by a reflection over the x-axis. The two figures are congruent because only rigid motions map. Sweet. So rigid just means that they're equal, and that's how it works. Very cool. They weren't the same size and shape. If we had a dilate, that'd be different. All right, let's do another one of these. So this is a reflection over whatever this line is. This is 1, 2, 3. So it's 1.5. Oh, because we got to do two things. So then it's followed by a translation. If I flip this over this line, it's just going to be here, and then it's 3 units to the right. I'm pretty sure that's what's going to happen. Let's see. Oh, I started with the other one, and it still worked. Yes. Yes, it didn't matter which one we started with. They are congruent because only rigid motions. So rigid means the shapes don't change, not like a stretch or a dilation. All right. Determine if the two figures are congruent. I can't really tell. I'm gonna go with yes because only rigid moves maps. Point corresponding to n is u. This one we'll go with. I think this matches to this. Let's see. Nice. Whoa. Then they spin it, right? Nice. They look the same. All right. So we're up to corresponding parts of corresponding figures. So 1 and 2 are congruent. Would matches to O. O matches to B. Remember the congruent symbol is just an equal sign with like a mustache on top. This is equal in size. That means equal in shape. All right, now we're doing similar. Okay. 1 and 2 are similar, which matches to angle X. X matches to I believe X matches to K. I believe they are the match. Nice. The dilation and a reflection at the same time. Wild. All right. Uh, no, they're not. Is not congruent because it cannot be made by rigid motions. It is not similar because they cannot match. So it's just not the same shape. You want to look at a new problem like that. These are not congruent because they cannot match, but they are similar, and similar just means same shape, but don't have to be the same size. So how much bigger is it? This is one space, this is 1, 2 space. I believe it's just twice as big. I believe it's just 2 times bigger because this is a line of 1 and this is a line of 2. That's what I'm going with. Rotated and stretched by a factor of 2. So remember, this is same size because it's equal, and this one's same shape. So if it just has this piece, it's similar. Cool. All right, let's do it up. Now we're using a vector. So draw a vector that's 3 units to the left and 2 units up. So 3 units to the left and 2 up. Oh, they want to start at the origin, sorry. So 3 units to the left and 2 units up. There's our vector. And move the tail of the vector to the vertex of the figure. Ta-da. Oh, we got to put one on each, and you'll see how to use vectors. They could all be right there. This will map onto the new point. This is using a vector to do it. Come on, come with me, friend. Ta-da. You are done. We did it. Ta-da. It looks 3 dimensions, which is cool. All right, let's rotate around a point. So draw a circle centered of this and one of the vertices. I'm not going to mess this up again. Boom. Now we draw the line through this to the one that we have. And now we know this slant is we go down 1, 2, 3, 4, 5, 4 over 1, 2, 3. So it's down 4 over 3. This one has to be up 4. 1, 2, 3, 4 over 1, 2, 3. Oh, sorry. Down 4 over 3, up 3 over 4. My bad, my bad. Up 1, 2, 3. I didn't make it perpendicular. There we go. Now we just have to rotate it 90 degrees, counterclockwise. Go for a little walk, friends. I went the wrong way. I drew it like a clock. There it is. So here we go. So if we're going 90 degrees, but we're not around the origin, so everything's going to be a little bit different. So this point was 6, -3, and now it is 7, 4. This point was 2, -3, and now let's do this first one. 1, -2 is now 6, -1. This point was 4, -1, and now it's 5, 2. And this is your final point, which is 2, -3, which is now 7, 0. I think this is it. This was hard. All right, let's do determine the line of reflection that would map the pig finger onto. Okay. The pink finger onto the dotted lines. All right, so we just got to get this line of reflection. We're getting close. Almost there. There it is. There's the line of reflection. It hits a -4 and its slope is, oh, so it's -1x, -4. Cool. Nice. -1x, -4. I got the line right too. Very cool. All right, let's do another reflection. Click and drag to draw the lines connecting the points from the figure to its reflection. Okay, so we got to draw the lines to connect the points. Nice. Okay. Now plot the midpoint. So where's the middle? Ooh. All right, so gotta plot the middle. Can't really see it, but I think it's here. I think it's here, and I think it's here. I think those are the middles. And we draw a line through the points. I know, just not great with the mouse. The slope of the dotted lines, it's 1/2, so it's 1/2. Oh, at the slope of the dotted lines. This is -2, because it's got to be perpendicular. -2, and this should be 1/2. The equation of this line, well, it hits at 2. So equation of the line from y equals, it's 1/2 x, because that's our slope, and our y-intercept is +2. Let's see how that goes. Nice. What a good problem. All right, here we go. Oh, we get to go second. That was the easy one? Okay. Reflect over the line, -1, 2. All right, well, we just go diagonal. 1, 2, 1, 2. That's how I always do it. 1, 2, 3, 4.5. Half, 1, 2, 3, 4. I believe that's there. And then we're going 1, 2, 3, 4, 5, 6.5. 1, 2, 3, 4, 5, 6. As you can see, a ruler would make this so much easier. We didn't have a ruler. So, boom. I just used the count method, which I like. All right, level 3. Okay, I don't know why this one's harder. Oh, because there's a little bit. Okay, so this is tough. All right, without a ruler, this one sucks. I'm not going to make you do the level 3. All right, let's do this one. All right, so triangle is congruent. LT, angle L matches to angle T. Oh, because it's flipped over. Crazy. I believe this was a rotation. Clockwise until point L has the same about point L. Oh, okay. So if we go clockwise around point, I think it's clockwise around point M until LM has the same slope as MT. I'm just looking at it, trying to spin it in my brain. Oh, nice. So we got that right. It is possible to say it's congruent by the what? We have angle, I believe it's angle side angle. We know that angle is true. We know that angle is true. I believe it's angle side angle because the side matches. I'm going with the A angle side angle using rigid motion. So let's see if that's true. What? Angle side. Oh, it's side angle side. Oh, give me a break. Oh, they did angle side? Angle side. And I And I use angle, side, angle. Angle, side, angle. That's what I thought, but it's angle, angle, side. All right, let's try another one. To get from there to there, it's a rotation around point M until LN matches AB. And I'm going to say that it's congruent because of angle, angle, side, because I don't want to mess it up again. I believe it's the same problem. What? Now it's side, angle, side? All right, well, might as well try a new one. This one is a translation till point X aligns to point K. Beautiful. And this is side, side, side. All the sides match. It's hard when I can't draw on it. Side, 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 side angle, side angle, side angle. Okay, let's try another one. What? That was just level one? Woo! Now we rotate counterclockwise. You rotate RST counterclock. Is it counterclockwise? Counterclockwise until S around point. No, we can't do that. We can't do that. We have to reflect over the line. Oh, it's two. So we reflect RST over line RT. I reflected over RT, it's that way. That doesn't work. If I reflected over ST. Okay, there we go. ST. This is really hard without drawing. Cool. Then we translate until the point S matches B. S prime matches B. Crazy. What? All right, well, it's not S matches B. It's still R matches A. Oh, because I put A instead of B. It doesn't matter which point. You just have to stay consistent. Nice. They are true because we rotate around one angle and we have a side, it's angle, side angle. I think this is what they want. Angle, side angle by rigid transformations. Did I get it right? What? It's angle, angle, side. Because look, I said, well, I had the right thing, but I thought that the side was in the middle, but the side that it matches is on the outside. That's the side that matches. So it's angle, angle, side. Okay. So try some of these. They're nice and tough. If it's congruent and WM is 15, we can't get it. We can't determine it because look, CV is here and we have this one, so it's not in the same order. Nice. It had to be the same order. I'll show you that again. All right, so if we have triangle OTJ is congruent to BHI, TJ is 5, then IB we can't get because it doesn't match. We can get HI, but we can't get this one. Nice. All right, let's keep. Oh, we're almost done. So here, let's do some easy ones, thankfully. Let's find the scale factor. The right triangle on the right is a scale copy on the left. It's 0.5. We're just dividing it by 2. What? Yeah, it's 0.5. 0.5 is 1/2. 0.5 is 1/2. So this is just 4. I can't believe they wouldn't let me put a decimal. That's so stressful. Oh, okay, so this is 16 over 20. So it's 20 divided by 16. They really want a fraction. We divide it by 4, so it's 5/4. I hope they will accept 5/4. All right, cool. All right, level 2. If one wasn't hard enough, well, 50 over 11 doesn't simplify, so I don't know how this one is harder, but that's okay. Oh, because it was the other way. I gotta just read the problems. So the square on the right is a copy on this 20 over 32, which is 10 over 16, which is 5/8. So you can just simplify these. You're going to be fine. What? It's the other way. Oh my God. The triangle on the right is a scaled copy on the left. So we need the fraction. So it's the other way around. It's 11 over 89. I don't like these. I think the other way is way better. It's just weird. I'm gonna take this one out. You just have to do the regular scale factor. The level 2 where it goes backwards is just poor writing. Okay, figure on the right is scale factor on the left. Which side corresponds to Kn? It's UQ. What's the scale factor? I always use the smallest one. So this is 1, or like this is 3, and this is 1, 2, 3, 4, 5, 6. So it's twice as big. 3 times 2 is 6. Beautiful. Oh, they use the smaller one, 2 to 4. Yeah. I just like using the straight lines. All right, let's do level 2, which matches to DB. DB matches to V dub. The scale factor is 1, 2, 3, 4. And the scale factor is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 3. So 4 to 6 is the same thing as 3 to 2. So it's 3/2 bigger. That was harder. Nice. And I use the same one as me. Use the 2 flat sides. Really cool. Okay, let's go one more level higher. The figure on the right. What matches to IJ? IJ is BC, I'm pretty sure. And the scale factor, none of them are straight. But I can use this one. This is 1. A to B is 1, and this is 2. So it's 1/2. Just gotta be, I use the diagonal to make the straight line. What did they do? Oh, they went up 6 to 3. That's cool. That is cool. I went diagonal. All right. On a grid, plot the figure A, B, C, D, F after dilation of a scale factor of 3. One of the sides has been plotted for you. Oh, okay. So if this was 1, 2, 3, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that's the first one. So this is E, this is 1 up, so this has to be 1, 2, 3 up. Okay, so that is 2 to the left, so this has to be, what's 2 times 3? 1, 2, 3, 4, 5, 6. I'm literally just multiplying everything by 3 because that's a scale factor. This is 1, so it's got to be 1, 2, 3. And we did it. Does it look like the same shape? Yeah, it's just 3 times as big. Ta-da! Really cool. All right. Oh, we get to do a level 2. So plot the image of Q with a scale factor of 2. They already did U to T. Okay. So this piece going down is 1, 2, 3, 4, 5, 6, 7, 8. So this has to be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's the Q. Oh, and then I gotta go over. So it's over 1, 2, 3. So it's over 1, 2, 3, 4, 5. Oh, sorry, just over. So this is over 1, 2, 3. So this has to be over. I just lost it. This one's annoying. It's too hard. We're gonna leave them at one level for you guys. Nice. Let's do a word problem. Scale drawing has 1 centimeter equals 80. What is the perimeter? Equals 80 meters. Okay, so we have to literally multiply both of these by 80. So that's 240 on the bottom. We have 4.5 and we have 3. So 3 times 80 is 3 times 80. That's 240. And that's 240. And then we need 4.5 times 80, or 4.5 times 8. So we're going to have an extra 0. So that's 40. Carry the 4. 8 times 4 is 32. Plus 4 is 36. We move to 1 decimal. So 360. 360. So 240 and 240, that's 480 plus 720 is 1,200 meters. Add a multiply by 80 for each of them. And then we add all the sides up. And let's do one more level of this. Serenity is planning a drive from city X to city Y. The scale 1 inch is 25 miles. If Serenity drives at an average speed of 50 miles per hour during the trip, how long is it going to take? Okay, so 2 inches. 2 inches is, if 1 inch is 25, 2 inches is 50. If she does 50 miles per, oh, well, it's just 1 hour, no minutes. Crazy. Yeah, why not? These are good problems. All right, here's pretty much the end. The segment TU is dilated, so we just have to multiply by 3/4. Dilation rhymes with multiplication. 12 times 3/4. All we have to do is make this other side into a fraction. I'm going to simplify. 12 over 4 is 3, so we know it is 9. The new D, it's 9. And this would be dilation from the origin 3/4. So it's going to go from, most likely would be dilating it from this point. They don't really tell us, but they could give you a point too. Yeah. Oh, I gotta reload it. Guess I did too many in a row. And we got 2 to go. What? Oh, it's saying it was that, so it's backwards. Whenever they do it backwards, I never understand what they're asking for. All right, let's do a new problem. The segment below is after a dilation of a scale factor of 2. So this was multiplied by 2 already. So what's the first one? 36. I guess I just didn't read. It does give you the prime. It shows that it's the new picture. Okay, cool. All right. And the last one that we have for changing, composing, decomposing, moving pieces around. Oh, there's 2 left. Dilation of a point. What is the image by a scale factor of 4 centered at the origin? So this is dilation from the origin, comma 4. So it's just the same point, just multiply each by 4, -16 and 8. Hopefully they give us a picture. No picture. And then I just have this one for fun. Identify triangles of a type. But this is one of the ones on your quiz I just made, so I wanted to add this in. So scalene means all the sides are different. It's definitely scalene. And are all the angles less than 90? Nope, it's actually obtuse because that's bigger than 95. So it's scalene obtuse. Do one more of them. This is scalene as well. And this is right because there's a 90-degree angle. And let's do a third one just for fun. Isosceles obtuse. Isosceles obtuse. Cool. So on yours, it asks you to fill in the blanks for that one. Okay, I hope that was useful. We did all of the first geometry. I know it took a while, but hopefully you learned a lot. And if you've got questions, just reach out and have a great day.